Hello Physics 1 students. So this video is going to go over how to do the calculations and the graphs for Lab 6. Now Lab 6 is going to be exactly the same for both face-to-face students and remote students. So if any face-to-face students happen to stumble upon this and this helps you with the calculations, that's great. You're going to be doing exactly the same thing, so don't feel like you can't use this as a tool to help you. Okay? So what I'm going to do first for my remote students is I'm going to show you where you can find this file that has the accelerations in it. Okay? So I'm just going to click on general physics. You might be in university physics, but the pages are set up somewhat similar. So you're going to look on the left-hand side for the option that says groups. Then you're going to click on that. And then you won't have all these options like I do. I'm an instructor, so I can see all of the different groups. But you'll have your group. I'm just going to click on this one because there's nobody enrolled in it. So when you're in your group, up here would be where it says the names of your group members. And then down here under group tools, that's where you have the file exchange. So you'll click on the link that says file exchange, and then you'll see that there's a file called Lab 6 Accelerations. You'll click on that and it'll automatically prompt you to download it. Now, as I mentioned, I already have it open, so I'm not going to download it. I'm just going to bring that window open. Okay? So this is what your file should look like when you download it. It's going to have the 5 accelerations filled in for table 1 and the 5 accelerations filled in for table 3. So it's going to be your job to calculate all the other columns, right? These guys here and then these guys here. Okay? And that's what we're going to go over right now. Okay? So if you do happen to forget what the equation might be, or you just in general weren't sure what it was going into this, I have kind of a little bit of a cheat sheet up top here. So obviously this one says that it's Capstone. That's the data I collected from Capstone in lab today. But the other ones are all calculations that you can do. Okay? Now, another thing that I wanted to mention, sidebar comment, please do not just copy this whole bit right here and paste it into your data section and think that that'll count for your equations being included in your abstract. Your abstract and your data section are not the same thing. You need to include these equations in your abstract, okay? So please make sure you include all of these equations, including this one down here, your percent error. Make sure all of that stuff is in your abstract, otherwise you won't have full credit for them being in your abstract. All right, so the first calculation that we need to do is we need to find the total mass. And as we can see up here, that's going to be little m plus big M, right? So we do equals, we click on the cell for little m, which is B3. We add it to the cell for big M, which is C3, and we get 0.7. Now we can just propagate this down because we used the cells, right? And if you want to spot check yourself, you can always double click and make sure that it grabbed the right cells when you propagated the formula. And of course it did, so we're all good. So now what we can do, now that we've calculated our total mass, we can come over to table 2 where it asks for our calculated total mass and we can fill in 0.7. That's going to be the same for everyone. Everybody should have 0.7 for their calculated total mass. All right, now we're going to move on to the next thing, which is delta M. So if we look at our formula up here, this is big M minus little m. So that's exactly what we're going to do. We're going to do equals. We're going to click on C3, which is big M, minus B3, which is little m. And we're going to propagate that formula down. You can always spot check, and we can see that it has calculated the formula correctly or propagated the formula correctly. All right, but what we can notice right away is that delta M is increasing, right? At first, we have a difference of 20 grams, then we have a difference of 100 grams once we get to the last run. Okay, and what I want you to notice here is that the acceleration values that I gave you are also increasing, right? And this makes sense, right? Because the disparity in the mass is increasing. It's kind of like a seesaw. The way that we have this set up is we have a mass that has 340 grams on it, and it's attached to a string that's run over a pulley, and it's attached to another mass that has 360 grams on it. So what we do is we move the larger mass, so the 360 gram mass, up right next to the pulley, and then we let it go, and capstone calculates the acceleration, okay? And so essentially what we do have here is kind of like a sophisticated seesaw, right? If you're on a seesaw with your friend and you're both close to the same mass, you'll both kind of, jump up and down, balancing each other out. But if you were to take somebody who is 250 pounds heavier than you, and you're sitting on the ground, and then they go and they get on the seesaw, right? So that would be more like this situation down here. They get on the seesaw, they're going to plummet to the ground like the heavier mass that they are, and you're going to go flying upward like the lighter mass that you are, right? And so that's exactly what we can see here with the accelerations, right? We have this huge mass disparity, and that's why our acceleration is so much bigger down here than it is up here. All right, so now let's calculate our last column, which is our net force. And we can see from our equation up here, it's going to be delta M times G. All right, so we're going to do equals, delta M is E3, right, times 9.8. And that's pretty much it. All right, so then we're going to propagate that equation down. Not surprisingly, it's increasing, right, because G is a constant. We can see every time we click in this cell, it's times 9.8, times 9.8, times 9.8. So the only thing that's changing is this guy, right? Delta M. And we already know it's increasing, right? So it stands to reason, of course, the force, the net force that's dependent upon it, would also be increasing. So now we're done with table 1. In order to complete table 2, we need to do graph 1. So I'm going to pan over here to Lab 6, the slides. Now if you're in the remote groups, you might be a little confused right now because I directly linked you to the video instead of any slides. So if you do want to look at these slides, they're just the face-to-face slides, okay? So I'll just refresh your memory about where those are. So if you go to courses, you navigate to the one that's your lab course. I'm just going to click on the one that happens to be my Friday afternoon one. All of my Blackboard lab pages are set up the same. So you go to course content, and if you're a remote student, you have my permission. Go ahead, click on the lab slides for face-to-face, and look at lab 6, because your labs are exactly the same. The methodology was exactly the same. Okay? And so if you want to look at the example data, you just scroll all the way down to the bottom, and that has all of the example data that is in the slides that I have open right here. Okay? If you want, you can look at the experimental setup of the masses, but I kind of don't think that'll be really that helpful to you. But you're welcome to look at it if you'd like. All right, so let's get back to the Excel spreadsheet. So I'm going to click way out in Never Never Land because I'm adding a graph. So the reason I do that, just to remind you, is so that it doesn't start grabbing information from a table. So if I click right here and I try to insert a scatter plot, it's going to start grabbing data from this table probably, and it might not be the data I want it to grab. All right, so that's why I'm going to click out in Never Never Land, click Insert, and then Scatter. Okay, now I have a blank chart, right? And you can see up here, we have the Design tab selected. We're going to click on Select Data, click Add, and then we're going to give it a series name. So if we look back at this graph, we're going to have the net force on the y-axis, and we're going to have the acceleration on the x-axis. Okay, so that's how I'm going to set up my data. So it's going to be F versus A. Always when you're titling a graph, it's y versus x, or a descriptor of the slope. Okay, then for the x values, let me navigate back to my Excel spreadsheet. For the x values, remember that's A, so we select those. Then for the y values, that's F, so we select those. Okay, then we click OK, and we click OK again. Now I'm going to add in a quick layout, because if I do that after I add in my trend line, it gets rid of my trend line. So rather than doing that twice, I just add this in first. All right, now what I'm going to do is I'm going to right click one of my points, click Add Trend Line, and then just check the box that says Display Equation on Chart. You don't need to do anything with that equation. It's fine just the way that it is. So now we have our slope. So what I'm going to do is I'm going to take this slope, I'm going to copy it, and I'm going to paste it where it says slope. Okay? So now I've got that value. The last thing that I need to do in table 2 is I need to use this equation down here for percent error, and I need to calculate my percent error. All right, so we have equals 100 times the absolute value of our calculated value minus our slope value divided by our calculated value, right? And you can see I get 5.72 runaway decimal places, right? So if you look back at the example data, you can see everything is rounded off to the third decimal place. And that's because that is the precision of the maximum precision of our measuring device. If you want to round it off to 2, that's okay, but I don't want to see any values that exceed 3 decimal places, okay? Because we know 3 decimal places for the mass, we know 3 decimal places for the acceleration. We can put in 3 decimal places for gravity, okay? Speaking of which, if you want to use like a gravity calculator like this, or if you want to look at what the average value would be out to more decimal places everywhere on the Earth, you can use this. All right. But the reality is that depending on where you are, the gravity is going to be different. So just keep that in the back of your mind. Not really because it's relevant to this lab, it's just a fun thing that you can mention to people at parties, and people will think that you're really super cool. Well, actually, maybe that's why I spend a lot of Saturday nights alone with my dog. All right, moving on. So, if we get back to our graph, now we've calculated everything for table 1 and 2, and so we want to make sure that we round everything off to the correct number of decimal places, which, as I mentioned, you can do 2 or you can do 3. Do not exceed 3, so we're going to do that for our tables, okay? All right, you can do 2 or 3. All right, so now table 1 and table 2 are completely done. Your graph is not done. Make sure that if you're following along doing this, you put in your axes titles and your units, okay? Even though I neglected to do that, do make sure you do it yourself. All right, now we're going to come down to table 3. We're going to calculate delta M. Same way we did before, right? So big M minus little m, right? Equation's right here. So equals big M minus little m. All right, we're going to propagate it down. This time, this is constant, right? It's not increasing. It's constant. And that's by design. If we go back and if we look at the slides for part 2, well, the net force is constant. Also, by default, delta M is constant, okay? And so I'm gonna skip 1 over the total mass for now, and I'm gonna go over to net force since we're kind of on the topic of delta M, and to calculate net force, we use delta M. Okay, so we're going to do equals, we click on delta M, multiply by 9.8 or 9.81 or 9.807, whatever you decide to do, or the latitude value that you get. All right, whichever one you use. All right, use that to calculate. Probably 9.8 though. All right, so now we have 0.98, and just like before, when we have our constant value, this is our calculated value, right? So we're going to do 0.98, or whatever variation you get of this using the gravity value of your choice, okay? All right, so I guess before I do this real quick, I just want to really hammer home the point that obviously this is constant, right? Because we have delta M times G. G is constant. Delta M also is constant in this case, right? Okay? And so once you calculate that value one more time, you're going to put it in as your calculated value over here. Okay? Last thing that we're going to do is we're going to calculate 1 over the total mass. So we do equals 1 over, and I like to put the denominator in parentheses. So we have big M plus little m, and we hit enter. Now, when we drag and drop this formula, we should notice that this is decreasing. Why, you ask? Okay, well, that's because we have 150 grams and 250 grams. Then we have 160 and 260. And then by the time we get to this last one, we have 190 and 290. So both of these are increasing as we go down. Well, in this case, we're dividing 1 by a bigger and bigger and bigger number, right? Every time that we divide it by the total mass is bigger, right? So if we divide 1 by a bigger and bigger number, we get a smaller and smaller number, right? And that's exactly what happens, okay? Now remember, we're done with table 3, but we want to make sure that we round off, okay? So you can round it off to 2 decimal places or 3. Both are totally fine. Do not exceed that. So before you saw I had those runaway decimal places, I do not want to see that. Then you'll be creating your graph. And very much the same way that you created this graph, you're going to create your other graph, with the whole select data and manually choosing what's on your X and Y axis. Now, for graph number 2, that's this guy right here, you're going to have A experimental on your y-axis and 1 over the total mass on your x-axis. So that means you're going to have this on your y-axis and this on your x-axis. Okay? So one last reminder before I go, please make sure if you're following along with this video, if you have not done it already, make sure you put in your axes titles and your units. Same thing is going to go for when you create graph number 2. Don't forget to calculate your percent error. Don't forget to put the slope in table 4. And that's pretty much it. All right, so hopefully you found this video helpful, and best of luck working on Lab 6.